This invisible element links volcanoes, oceans, and the sky. What is it that connects a roaring volcano, the vast silent ocean, and the very air we breathe? It is an element often unseen but always at work. This element is sulfur. It travels on an immense journey around our planet. This is the story of the sulfur cycle, a quiet engine that shapes our world. The cycle is a delicate dance between land, the sea, and the atmosphere. It begins deep within the Earth's crust, locked in rocks and minerals, waiting to be released. Heat and pressure can drive it upward. It emerges from volcanoes and from quiet decay in soils and wetlands. Sulfur is primordial. This cycle has turned for billions of years. And sulfur is not just a passenger, it actively shapes systems. It influences our climate, provides nutrients for life, and can threaten delicate ecosystems. Understanding its path reveals Earth's web of connections, from the deepest ocean trench to the highest air. Our story begins with fire and fury. We will follow sulfur into the sky and watch it return in rain. Life, from microbe to whale, depends on this cycle, a hidden engine powering our remarkable world. The sulfur cycle often begins with a spectacular eruption. A great plume of ash and gas billows into the atmosphere. Inside is sulfur dioxide gas, invisible but powerful. It is Earth's deep interior breathing out. Big eruptions can push SO2 into the stratosphere, a calm layer where it can linger for years. Driven by sunlight, it meets oxygen and water vapor. SO2 transforms into tiny droplets of sulfuric acid and into sulfate particles, aerosols. These particles are so small they can stay aloft a long time, forming a fine, often invisible haze. Winds carry them far from the volcano. One major eruption can spread haze across a hemisphere. Satellites track these invisible clouds circling the globe, showing how one event affects faraway places. The journey also begins in the deep ocean. Vents release superheated, mineral-rich water laden with hydrogen sulfide, another sulfur form. Tiny bacteria use this energy, forming a unique food web. Some sulfur moves into vast ocean currents, joining the global cycle at the sea surface. Once suspended high above, these aerosols begin to shape sunlight itself. After Mount Pinatubo in 1991, global temperatures cooled for a year or two. Sulfur particles also seed clouds, making clouds with more, smaller droplets, brighter and more reflective. This cooling is part of Earth's natural balance, but the system is complex and far-reaching. Human industries add sulfur dioxide to the lower air. Coal, oil, power plants, factories. What goes up must come down, as rain, snow, and fog. In clouds, sulfur makes weak sulfuric acid, which falls as acid rain. It weakens forests over time. It can acidify lakes, harming fish, amphibians, and insects. It slowly dissolves limestone and marble. Scrubbers and cleaner fuels have cut SO2 in many places. In balance, sulfur deposition is helpful. Plants take sulfate from soil to build proteins and vitamins. In the ocean, phytoplankton make DMS, a sulfur gas. It escapes, forms aerosols, and seeds clouds, a beautiful feedback. On land, sulfur flows through plants, herbivores, and predators. When life dies, microbes return sulfur to soil, water, and air. Over ages, sulfur locks into rocks like gypsum and pyrite until tectonics and magma lift it to the surface again. From fire to clouds, from microbes to forests, sulfur is a constant thread. If you learned something new, hit like and subscribe.